Chapter 2, Section 2 is analyzing conditional statements. So, you guys are actually used to conditional statements all the time because you deal with your parents all the time. Can I go out tonight? You can go out tonight if you do this. You can go out tonight if your homework is done, if your room is clean, whatever your conditions are. But you guys are used to conditions. Things can happen if something else happens. And that's what conditional statements are going to be, is that one thing can happen if another thing happens as well. So that's what we're going to look at. So if you're not in the notes yet, get those notes open for 2-2. The first thing we're going to talk about, and these are the parts, this is like, the next two slides are like the only slides from 2-1 that I pulled out. They are terms that you're going to hear a lot and they come up. So I just want to make sure that we've addressed them. The first term that you're going to hear a lot is a conjecture. It'll say make a conjecture. A conjecture is just an unproven statement that is based on an observation. Sometimes we see something that happens all the time. Like I even told you, I made a conjecture just a few days ago. I said, hey, make sure that you do really well in this next test, because my conjecture has been that when students don't do well on the first test, that they tend to get stressed out. If they didn't do well in the first quiz and you didn't do well in the first test, they tend to get stressed out and they tend to get depressed about it. That was a conjecture. That's not like a fact. That's not, I mean, it has happened, but those are just based on my observation. That's not a proven fact. I didn't do any science behind it. It's just my observations about a pattern that I see. So I looked at a pattern that I see and I made a conjecture about it, which is an unproven statement that is based on an observation. So you might be asked to look at a pattern and make a conjecture about what is going to happen next. That's what we're talking about there. And to do that, we are going to use what we call inductive reasoning. Inductive reasoning is not just a math term. When you use inductive reasoning, that is what you are doing when you look at patterns and then make a conjecture. I see something happening. Every single morning, my dad wakes up and he's grumpy. You go, so you're just seeing a pattern. You're like, okay, I'm looking at a pattern, so I'm going to make a conjecture then and say, tomorrow morning when my dad wakes up, he's going to be grumpy as well. Why? Because I looked at the last 5 days, and every single morning he woke up, he was grumpy. Maybe he's not getting enough sleep at night, whatever it is, I'm just making a conjecture. He might wake up tomorrow and maybe he won the lottery the night before, and maybe he's super happy. It's not like a proven fact. It's like a hypothesis about what's going to happen next, but it's a logical hypothesis saying, here's what I believe will be happening next based on the information that I'm seeing. So, for example, it says we're going to use inductive reasoning to make a conjecture about this fourth figure here. It says describe how to sketch the fourth figure in the pattern, then sketch the fourth figure. So we've got 3 figures going on, and the idea is it's going figure 1, then figure 2, then figure 3, and by looking at those, we're supposed to figure out what's going on and then accurately sketch figure 4. And figure 4 should actually look exactly the same for all of us. So let's not just skip to the end, let's talk about what we see. Let's have an open conversation. What do you see there? Yes, sir?
It goes like 2, 4, 6, and then the next one is 8, like halves.
Okay, so he's saying it goes 2, 4, and then 6. So we expect that the next one would be 8. So there's 2 parts in here. Like you can see, there are 2 parts to this. There are 4 parts. Then there are 6 parts. So it's not just each one being divided in half, because this is the circle divided in half, and then it got divided in half again. If I divided this in half, like let's say I did, I'm just going to do something here just to show you. Just if I went like this, then I would expect that there are 8 pieces. But the third figure does not show 8 pieces, so that would not be a valid conjecture. It doesn't go with the information that I'm seeing. So saying that they're 8 would be incorrect. But saying that they were 6, that does follow the pattern there, that we go, oh, okay, it goes 2, 4, 6. And my expectation is here, and I'm going to let's go to yellow. I'm not so worried about the colors here. You're using Notability. I am not at the moment, so your circles will hopefully look better than mine. I'm going to make a circle. I'm going to try to make it relatively the same size. And now I'm expecting 8. So that figure that I expected for figure 3 is actually what I'm going to draw here. So I'm going to divide it in half. I'm going to divide it in half again. Now I have 4 pieces, and I need 8. So I'm just going to take those halves and cut them in half. Now that is definitely part of it, but it's not all of it, because there's something else going on. And this is the tricky part, because I would say you might be teetering in between two ideas now, and I would say one of them is more correct than the other. Because if you are looking at this and saying, it could be this or it could be that, I would say there's a logical argument for one of those two things. So don't worry, by the way, we all just get to take guesses at it and go, okay, it's totally okay to be wrong in here. Totally okay. I'm not going to ever make fun of you. Well, I'll make fun of you, but not for math. I make fun of you for the fun stuff. Any guesses as to what we might do? Yes, ma'am. I'm going to shade one. Does it matter which one? Like, let's say that I decide to do this. How do we feel about that?
No.
I agree. I feel like that lower right-hand one would not be a good one to shade in. So let's come up with something better. If it's not the lower right-hand one. Okay, so wait. I agree. Top left. It seems they're all in the top left. But wait a minute. Which one of those is the top left? And that's what I need a valid argument for, is that I would say of those two, I feel like we all go, hey, it's in the upper left-hand corner. But I would say two of those are kind of the upper left-hand corner. One of them I would say is a better choice than the other based on the pattern I am seeing. Yes, ma'am.
The one on the bottom.
Why the one on the bottom? Because I would agree with you.
Because like from figure 2 to figure 3, it got the one on the bottom half, so you probably have to do the same thing for figure 4.
So I like the way she explained it. I was actually going to explain it differently, but our explanations are the same. So she's saying here, you can't really tell. Here, you can't really tell. But from figure 2 to figure 3, they chose the bottom portion of that. Well, here's what I would argue, which actually goes along with that, is that every single time the blue portion is touching this line. Would you agree with that?
Yeah.
So whatever I shade in there of those two should be touching that line, and I think the only one that meets that criteria is right here. So I'm using a pattern, and there's really kind of two patterns going on there. One deals with how many pieces there are to the circle. The other one deals with which piece are we looking at of those pieces? Which one are we identifying? So there's two. Now we used a conjecture. We used inductive reasoning to make a conjecture. The inductive reason was we looked at this pattern, we tried to identify what the pattern was, and said, okay, now that pattern, if we had more of these, might actually be different. We don't know. The more things you have, the more easily you can recognize the pattern. So here we based it off the information we had, and this meets the same pattern all the way. So this seems like a logical, a valid conjecture here. This seems like, okay, this is probably the most solid thing I can come up with there. So far, so good? All right, so now we get into the very vocab-heavy area. And I will, again, unfortunately, you have a dork for a teacher, so he is going to give you a whole bunch of dorky tricks that you'll probably make fun of me for, but I will take it. All right, so now we get into these conditional statements. And you'll see that earlier I was talking about that you guys are used to conditional statements because you have parents. If you do this, then this will happen. If you punch your brother, then you will be grounded. That's a conditional statement, right? If you do it, this will happen. So we call the if part because when it says if you do this, that means that it hasn't happened yet. But if this happens, then this will definitely happen. Like, it is a guarantee. If you decide to punch your brother right now, then you will definitely be grounded. So there's like the part that hasn't happened yet. It's the, bro, you're at a crossroads. You decide to punch your brother. Here's what's going to happen. So when we have conditional statements, we have two parts. The hypothesis, and you're going to see, I'm going to color code a lot of this in red and blue. And we use this letter P all the time to identify the hypothesis. We're going to use the letter P to represent the part that is the hypothesis. And then we have the conclusion. So there's the if you do this, then here comes the conclusion. So the then part is the conclusion. And we use Q for that. What's going to happen if I do that? So here's the key thing. The word if and the word then, neither one of them, this is really important, by the way, because this is where people start to lose points on their next quiz and next test. They are not part of the hypothesis, and they are not part of the conclusion. It is like a marker that tells you right after the if, you can expect what is the hypothesis? If I do what? If you hit your brother, so here's my hypothesis right here. If you study. The you study part is the hypothesis. It does not include the word if. It's just You study. Then, here comes the conclusion. What is the conclusion? The conclusion is the part that comes after the then. You will get an A. So, conditional statements always have an if and a then part. And they are each followed by, the if part is followed by the hypothesis, the then part is followed by the conclusion. If you do this, then this will happen. If I whose phone is blowing up? So, I say this, I'm going to repeat this over and over again because this is the biggest mistake that I see in there that people are like, oh, I didn't know that. And I'll be like, you should go back to that video that I produced. Well, this is the video that we're producing right now. Is that the word if is not part of the hypothesis. The word then is not part of the conclusion. They are just our identifiers that here comes the hypothesis. Here comes the conclusion. If this happens, then that will happen. So there are two events that are related. And that's what we're going to be looking at today. So you're going to hear me talk about the hypothesis, and I'm going to always label it as a P. I'm going to talk about a conclusion, and I'm always going to label it as a Q. We write them like this. We have a mathematical way of writing it, and it looks like this. And what this means when we translate this out of math nerd speak is if P, then Q. That arrow means that if P happens, then it is a guarantee that Q will happen as well. It is a guarantee. If you hit your brother, then you will be grounded. So guess what? I hit my brother. You know what happened? What is the logical conclusion that happens next? You're grounded. That's it. You're grounded. So if I have this statement, if this happens, then the second thing will definitely happen. So you hit your brother, well, then you're grounded. That's how these statements work together. If P, then Q. That's how we say it. This is if P, then Q. That's how we say that in normal human speak. Okay. So, those of you, how many of you have younger siblings? All right. So you all probably understand negation better than anyone. Because younger siblings are pro at this. I have a younger sister. She annoyed me with this all the time. I happen to be the middle child, which means I annoyed my older brother with the same kind of thing. The negation of something is when we say the opposite of a statement. For example, the reason I say little brothers and little sister are great at this, because sometimes you can say whatever you want, your younger sibling will say the opposite no matter what. You'll be like, I'm so cool, and your sibling's like, you are not. You could be like, the sky is blue. They would be like, the sky is not blue. Whatever you say, they will just go the opposite direction just to be difficult. We call that a negation of a statement. It's not just because it's difficult, because there are two things that can be opposites. So sometimes I'll make a statement like, my shirt is red. And I say, what is the negation of that? And somebody goes, oh, that's the opposite. So I'll say, your shirt is blue. That is not the opposite of my shirt is red. The opposite of my shirt is red is your shirt is not red. Right? That's the opposite. If I say it's something, you say it's not that something. So we use this word not. A negation is saying the opposite of something. We are nodding something. It's like whatever you say. So if I were to say I am not cool and you were to negate that, you would just take the opposite stance and say you are cool. So a negation is always just taking the opposite stance. It's the opposite of the original statement. So if my original statement is it is raining, the negation of that is just it is not raining. Very simple. Just take the opposite statement. The shirt is not red. The shirt is red. Be careful because sometimes people think of things as like going like, if I say my house is on the right and I told you to make the negation, it's very like your brain tells you to go, your house is on the left. That's not the opposite of that. Saying my house is on the right, the opposite was your house is not on the right. That's taking the opposite of your statement right there. Whatever you're saying, I'm taking the opposite of that statement. I am negating it. So you're going to hear me use this word negation. It just means to take the opposite stance. And you guys are great with this with your parents. Whatever your parents tell you as a great idea, like here's what you should do, and you're like, you don't know anything. You know what I mean? Like we tell our parents because we don't think they understand what's going on. So that's the kind of thing there is negation. Little kids are good at it with you. You guys are good at it with your parents. Like you always take the opposite stance. So we are going to be negating some statements here in a minute. All right. Before we get into, we're going to start talking about some words. We're going to be talking about converse. We're going to be talking about inverse. We're going to talk about contrapositive. So here's where I get to be my dork person here. Let's not talk about math anymore. Let's talk about the real world. And I don't want you to think like geometry students. I want you to think like real human beings for a minute. If I am talking about converse, what's the first thing that you think of that's not math related?
Shoes.
Me too. I think of the shoes as well. Where do shoes go? What is the purpose of your feet? They walk, they move you around, right? So converse are shoes. Shoes go on your feet and your feet move you around. So this is my thought, is that we're going to have three different definitions here, and it's easy to get them all mixed up. So converse, move things around. So all we're going to be doing in this is moving things around. So when you see that word converse, again, if you know shoes, just know converse is a kind of shoe. It moves things around. And we form the converse. If I tell you to form a converse, you're going to take that conditional statement and move things around. We're going to change the order of the hypothesis and conclusion. And that's going to look like this. We start off with a statement, if P, then Q. And all we're going to do is swap the hypothesis and the conclusion so it looks like this. If Q, then P. Notice all I did was move those two things. And I'm actually going to show you with examples in a minute. But you're going to see these letters P and Q all the time. If you don't get in the habit of using P and Q along with everything else we do, this is going to be a very confusing lesson. That's why I go way overboard in the beginning. So let's pretend our original statement was if. Now here's what I'm going to do. I'm going to underline the if and I'm going to underline the then. If you study, that is my hypothesis, that's my P, then you will get an A. That is my conclusion. That is my Q. If one thing happens, then another thing will happen. That is my statement. And if I tell you to take this statement and make the converse of this statement, all you're going to do is you are still going to keep if and then in the same position. You are just going to swap the order of the letters. Now, sometimes I will warn you, sometimes you swap those two and the sentence doesn't grammatically make sense. So you'll have to make little adjustments. So if I say, if you will get an A, like you notice here it says like will get an A, that's a very weird statement, right? If you will get an A, if you will get an A, then you study. That's a very weird sentence. But we can change it slightly by just using the past tense. We say, if you got an A, then you studied. Now, I'm not trying to address whether that's true or false, because let's face it, how many of you have ever gotten an A on something and you didn't study for it at all? Right? It happens. It doesn't mean that it's true. All we are doing is making the converse of a statement. So it does not mean that it's true. Watch, for example, if you live in Florida, then you live in the United States. Is that a true statement?
Yes.
Okay. Now I'm going to take the converse of that. Let's take that. So let's come up with what statement that be. So if you live in Florida, then you live in the United States. Let's turn that into the converse. Let me write that first, just to see whether it's true or not. Oop, that's not a pen. If you live, oh, that shouldn't be capital. If you live in Florida, then you live in the USA. And we said that's a true statement. So now, notice, here's my if, here's my then, here is my hypothesis, here's my conclusion. So I'm going to flip that around and make the converse. If you live in the USA, then you live in Florida. What I have done was I have created the converse of that statement. Now, so now I've got if Q, then P. Is my second thing a true statement?
No.
Not necessarily. It doesn't have to be. Give me a counter example, something that shows that this second thing is not true.
You could also live in Georgia.
You could live in Georgia. And if you live in Georgia, like if you would still live in the United States, but you don't live in Florida. We call that a counter example. It goes against the statement. You're making a statement that is true. Well, let me show you why you're wrong with a counter example. An example supports something. A counterexample crushes something. It goes, nope. So, converse, again, are shoes. Shoes go on your feet. All we did was move these around. That's what I was looking for. So, okay. Inverse. That annoying little brother or annoying little sister that is always negating everything that you say, that is inverse. That is exactly, this is that sibling there. I'm going to make a little note here. This is just like that sibling. They are going to say the opposite of whatever you say. No matter what you say, they are going to say the exact opposite. So it's formed by negating both the hypothesis and the conclusion. So we're going to look at the original hypothesis, we're going to look at the original conclusion, and we're going to say the opposite of both of them. So watch what I do here is I say, here's my if, here's my then. So this must be my hypothesis, and this must be my conclusion. So I still need to have an if and then when I make the inverse, but now I'm going to say the opposite of if you study, I'm going to say if you didn't study. That is the opposite. That is the inverse of that. So the original was an if you study, then you will get an A. Well, then the inverse says if you didn't study, then you didn't get an A. That is the opposite of both things. We call that the inverse. So far, what we've got is our conditional statement. That's our original one, conditional statement, which looks like this. If P, then Q. And now we have our inverse statement. Oh, we did converse next. I'm sorry. Hang on. Hold that thought. Sorry, I forgot we did converse. We did converse. I lost my Q there. Converse. And it said move the P and the Q around. It just says now do if Q, then P. Now we're going to do inverse. The P and the Q are going to stay in the same place, but we're going to say the opposite of them. And the way that we do that with these letters is we do this like to the first power thing. And what that means is if not P, then not Q. That not thing just means say the opposite. So we've got conditional, we've got converse, we've got inverse. Remember, converse switches positions. Inverse is that annoying little brother or sister that says the opposite of whatever you did. And then we get to, yes, ma'am?
Are those ones?
They're really just like, we call them not symbols. It's if not P, then not Q, but I write them just like a one, just like a little, I would not write them like this though. I would not make them like that. It's not really a one, it's just a little like tick mark there. So it says if not P, then not Q. It just means the opposite of P, then the opposite of Q. So we get into our last one. Let me just see. Okay, and our last one is called the contrapositive. So we've done two things. We have swapped the order and we have negated them, and now we're going to do both of those things together. We are going to move their position and then reverse exactly what they say. So we are going to do the annoying little brother or sister wearing Converse here. They're going to do both of those things all at the same time. We're going to swap the order and then say the opposite. So we form a contrapositive by writing the converse. First thing we're going to do is swap their order, and then we are going to negate both of them. We're going to say the opposite. So the original, here's my if, here's my then. The original one said, if you study, then you will get an A. That's their original conditional statement. And it told us the first thing we should do is write the converse. So I'm going to write the converse. I'm still going to have an if, I'm still going to have a then. And notice now the conclusion comes first. The hypothesis comes second. So if you got an A, then you studied. And our last step to turn into the contrapositive is we have to negate both the conclusion, which is here. Oh, that's the wrong color. The conclusion that is here and the hypothesis here. So we're just going to say the opposite. So we've got if, then. We're going to say the opposite of you got an A, which becomes you didn't get an A. That is not Q. Then you didn't study. Now notice that's not necessarily true too, because I bet you have studied your butt off for a quiz or test. Maybe it was even for this class and you didn't get an A on it. So that's not necessarily a true statement or not. We're not talking about whether it's true or not. We're just saying it's a statement. And the way that that looks is, if not Q, then not P. Notice both the Q and the P have changed position, and I have negated them. I have made them the opposite. That's what that little mark means right there. I have said the opposite. So, quick summary. I kind of beat this in. I want this so beat into your head. So we've got our conditional statement. I'm just going to abbreviate here. That starts if P, then Q. We've got our converse. Remember, converse are shoes. Shoes move you around, so we're just going to swap positions. We've got our annoying little brother inverse, who's going to say the opposite of everything that we say. And now we've got the contrapositive, which does both. It changes position, so Q comes first, P comes second, and then we negate them both. So the P's and Q's are actually a short way of writing it. What do I do? Find that this is what you do to get them. The conditional statement, if it looks like this, then you swap the order for a converse. You keep the same order, you negate them for the inverse. You swap the order and negate them both for the contrapositive. So you could see where it's hard to remember this all if you don't start early. I'm going to leave it on pause while you could. On this next quiz or test, expect that you will be writing sentences. Like I will give you a conditional statement and I will say, write the contrapositive, which means that you'll have to have done these steps. You had to write the converse and then you had to negate that converse to get to the contrapositive. So there is a lot of writing in this that you go, wait a minute, this doesn't feel like math anymore, but I promise it all ties back to the math in it because this is where we start leading into our proofs. Bum, bum, bum. Before I go on. Okay. So now we get into false statements, and we agree that we have things that are true and things that are false. So we're going to be making statements, and then we'll talk about whether they're true or they're false afterwards. Just because we make a statement doesn't mean it's true. I could tell you that I am the most handsome geometry teacher in the world, and we all know that's a fact, but some people might disagree with that. No, I'm kidding. But honestly, like, you can make a statement. We don't know whether it's true or whether it's false, like, until we just examine the statement. So an if-then statement is false if an example can be found for which the hypothesis is true, but the conclusion is false. A moment ago we said if you live in Georgia, you still live in the United States, but you do not live in Florida. That would be considered a counterexample. So to find a counterexample, what we need to do is something that where the hypothesis is still true, people in Georgia still live in the United States, but the conclusion was false. They did not live in Florida. So this one here, it says if, then, if you live in Florida, then you live in Miami. So let's look at that. Here is my hypothesis. Here is my conclusion. So we are going to decide whether that is a true statement or not. Is it a true statement? No, so if it is not a true statement, then you need to give me a counterexample. Explain why. Give me an example where you live in Florida, but you don't live in Miami. Give me a counterexample. Yes, ma'am.
I live in Fort Lauderdale.
Okay, so if you live in Florida, then you live in Miami, that's not true because she lives in Fort Lauderdale, and that is in Florida, but she does not live in Miami. That is a counterexample. She met the conditions of the first one, but she didn't meet the conditions of the second one, which means that this is not a true statement. It's a false statement. So we identified it as false, and we provided a counterexample. All right. So now we get into a biconditional statement. It has two conditions. Bi meaning two, like bicycle, two. Two condition statements. If the conditional statement and its converse is true. So what that means is the conditional statement looks like this. If this is true and the converse is true, that's this one right here. If both statements are that says if Q then Q. If Q then P. If both of those things are true, then we can write it as a biconditional statement. We're going to rewrite it as a biconditional statement. If and only if are the words that we're going to use. We're going to combine the two statements with if and only if. So let's look at this statement right here. If then. So we've got if an angle has a measure of 90 degrees, then it's a right angle. So, first of all, is that a true statement that if an angle has a measure of 90 degrees, then it's a right angle? Yes, that is definitely true. So one part is true if the conditional statement is true. But now we need to see whether its converse is true. And we need to state the converse. So I know it starts with if, and it's going to have an then. So let's say, what is the converse of this statement? And again, you might have to play with the words a little to make a sentence that makes sense. Gio, take it.
If an angle is a right angle, then it has a measure of 90 degrees.
Good. If an angle is a right angle, notice he put the conclusion first, is a right angle. If that's true, then it has a measure of 90 degrees. Okay, so we made the converse there. That's the converse. Is that converse true? Yeah, a right angle definitely does have it. So if it is true, we are going to write it as a biconditional statement. Again, this is another area for accidents. Here's what we do when we make a biconditional statement. This is the part where you want to take superb notes. Here was my P. Here was my Q. Okay, that's what I want. So I'm going to rewrite it like this. P, I, F, F, Q. And this I, F, F, like it's the word if, but with two F's, it means if and only if. I could also write it like this. P, if, and only if Q. What this means here is when we make a biconditional statement, we are going to, number one, this is the biggest mistake. Throw away the words if at the beginning and then in the middle. We're going to throw those away. So watch, up that statement there, I'm going to cross off the if. I'm not going to use that. I'm going to throw it away, and I'm going to throw away this then. I don't want those. What I'm going to do is then I'm going to join the P and the Q with IFF in between. And we'll see what that looks like. So I need to start with the P part. So I'm going to go like this. It's going to be like, look at the end just like this. I'm going to do whatever the P is and then write IFF and then write whatever the Q is. So what is the P part? What is the sentence that is the P part? Like when I say P, what am I referring to in that sentence above? What is it? The hypothesis. But what specifically is the hypothesis in the statement above? Good. An angle has a measure of 90 degrees Now, I'm going to write the Q in just a moment, but in between them, what do I need to write? Yes, ma'am? If and only if. Now, you can write the actual words if you prefer, but I'm kind of lazy. I'm going to write IFF. It means if and only if. An angle has a measure of 90 degrees if and only if, now I'm going to my blue part, it is a right angle. Remember that this is being recorded right now too, so if you need to come back to it, don't worry, it's going to be on YouTube. So an angle has a measure of 90 degrees if and only if it is a right angle. That's a true statement, right? The only way that something is going to be a 90-degree angle is, if an angle does have a measure of 90 degrees, then it is definitely a right angle. It is true forwards and it's true backwards. The other way we can write it, and there's one last way that you will see it written, is that you'll have a P and you'll have a Q, and instead of having an arrow just going one direction, it goes both directions. That's called a biconditional statement. So notice we did everything with P and Q. Now this one goes both directions. It's true forward, it's true backwards. P, if and only if Q. So we had to identify which part is the P, which part is the Q. So big that you need to throw away the words if and then. I don't want to see the words if and then other than right here. It's okay to say if right there. But we don't say if at the beginning. We don't say then right before the conclusion. We just say if and only if in the middle. So a lot of people's brains get frazzled on this because when it comes to this, when it comes to the homework, when it comes to the quiz, when it comes to the test, it's going to ask you about conditional statements. It's going to ask you about the converse. It's going to ask you about the inverse. It's going to ask you about the contrapositive. It's going to ask you to make a biconditional statement. It's going to ask... And you're also going to be asked to make biconditional statements. So knowing the definitions of those things, there's not much you can do with these lessons if you don't know those definitions. So it's a matter of going, I better make sure that I've got something to differentiate these. All right. So it says if, now we're not going to write all this out, but we are going to talk it out so that you're welcome to write it down. It says if you attend AMHS, if you attend Archbishop McCarthy High School, then you wear an ID. I don't care if you think that's true or not yet. I'm just saying right now, let's break this down. It says using the above statement, identify the hypothesis and the conclusion. So somebody help me out and tell me what is the hypothesis in the above statement? Beautiful. I'm so glad you said you attend AMHS because a lot of people want to say if you attend AMHS. The if is not part of the hypothesis. It's not. It's just an identifier saying here comes the hypothesis. All right, so then what is the conclusion? Somebody else. Yes, sir. You wear an ID. Notice we did not include the word then because then is not part of the conclusion. It's just the identifier that says, here comes the conclusion. So, now we're going to state the converse, the inverse, and the contrapositive. Real quick note here, I'm going to write here. Remember the contrapositive means that they swapped places. They're like shoes, shoes move you around. The inverse didn't swap places, but that's your annoying little brother who just totally says the opposite of whatever you did. And then finally, the contrapositive is going to be where they swap places, and they're an annoying little brother. They swap there. So somebody give me the converse of the above statement. Yes, ma'am. Good. If you wear an ID, then you attend AMHS. That all we did was swap the order there. That's exactly, again, we're not identifying whether they are true or false yet. We are just making the converse. Somebody different, give me the inverse of the above statement. Remember, annoying little brother. Yes, ma'am.
If you don't attend AMHS, then you don't wear an ID.
Good. Again, we're not addressing whether it's true or false. She said if you don't attend AMHS, you can say it however you want. If you do not attend AMHS, then you don't wear an ID. All she did was take each one and negate both of them by saying the opposite. Finally, somebody different, give me the contrapositive. So you got to do both. Yes, sir.
If you don't wear an ID, then you don't attend AMHS.
Good. First thing he did was he swapped the order, and then he said the opposite of each. So he said the blue part first. If you don't wear an ID, then you don't attend AMHS. So let's decide. It says, is the converse a false statement? So we have to think about which one was the converse. What was the converse again? Yes, sir. Good. If you wear an ID, then you attend AMHS. Is that true?
No.
Okay, so if it's false, then give me a counterexample.
Because you can go to any school and wear an ID.
Yeah, if you go, guess what? If you go to American Heritage, then you wear an ID. So just because you are wearing an ID does not make you a part of this school. It is something that's required for here. You could be going to American Heritage. You could be going to another school. Other schools wear IDs as well. So that is the counterexample we're looking for there. Any other example where people wear IDs, but they are not. You could be a scientist who wears ID in a lab that has like ridiculous, like creepy bacteria. They may not attend AMHS. All right. Rewrite the pair of conditionals as a biconditional. So we're going to write this right there. So here's an if, here's a then. Let me just see it for a second. Okay, so what we've got here is the first one says if M is between L and N. So here's what we've got. Like if that was a picture, that would just look like this, just so you know what we're talking about here. If M is between L and N. Now it doesn't say it's in the middle, it just says it's between. If M is between L and N, then LM plus MN must be equal to LN. First of all, is that a true statement? Yes. The first part plus the second part would equal the total. So now the second part says if LM plus MN equals LN, so if the first part plus the second part is equal to the whole, then M is between L and N. Is the second part true?
Yes.
Yeah, it's true both ways. So what we're saying here is that if M is between L and N, there's our hypothesis, then LM plus MN equals LN, there's our Q. Now all they did is the next sentence that comes after that is the converse. They've already made the converse. So our job is to turn this into a biconditional. It could look like this, or it could look like this. But really what I need to see is the hypothesis joined with the conclusion with if and only if in between them. Which two words am I throwing away? If and then. They're garbage words. We don't use them in the biconditional at the beginning of each section. So somebody hook me up. I need the hypothesis, if and only if, the conclusion. Yes, ma'am.
M is between L and N, if and only if LM.
All right, I'm old and slow. Hold on. M is between L and N. I heard that. There's the hypothesis. And then what?
If and only if.
Okay. If, I'm going to write it out this time just to be different. If and only if. You could certainly use IFF, but don't do one F. If you do one F, you got it wrong. Two Fs means if and only if. One F just means the word if like we have in regular. So, if and only if.
LM plus MN equals LM.
LM plus MN is equal to LN, a biconditional statement. Yes, ma'am?
So on the test or quiz, we can write IFS?
Yes, you can definitely write IFF, but understand, and this is being recorded and uploaded so you have no back when this happens, because I will refer you back to this moment at 2 minutes and 57 seconds into this slide right here where I said you can't just write the words if, you can write if with two Fs, and it means the same thing as if and only if. You can either write out the words if and only if, or you can write IFF. Those are both acceptable.